Hello everyone, I'm Himans. I'm starting my new journey on YouTube to create exciting and fascinating videos about ML, and like my mostly work will be converting ML papers into working code, and let's have a look like how these stuff work. And I'm very first time, I'm not sure like I'm doing my videos well or not, so I thought like firstly start with the low level stuff, like high level stuff, and like little bit go dramatically to the low level kind of area. So this is my start, and like you guys, I hope you guys to like give me a good feedback on my conversation style video recording part, and like what I can improve. Also in terms of like technical knowledge, where I'm lacking and what I can improve to get more knowledge. I'm starting this channel for two purposes. One purpose, like I'll also be learning alongside with you guys to make videos more properly. And secondly, like I'm also sharing my knowledge here and my little bit expertise, how you guys can take it up. And yeah, that's it up. And like I thought, why like directly going jumping to the top level stuff, like directly converting papers into the working code and like checking their models, trying their strategy to build our models and all this stuff. Let's go a little bit slower. Firstly, like I'll be clearing all of your bases, 4 or 5 videos regarding that. From where like I'm starting from CNN, RNN, and like I'll be going to a transformer. Variant types of transformer and all this kind of a neural network we will be learning of the deep network. And this is like more where I have interest lie in. So let's get started. I'm going to like have the conversation on convolutional neural network, and I'll be giving a very small intro, and like you can think of go through. Firstly, I'll telling you the concept, and after that, I'll be giving a small demo of the code and all this stuff, how all this is working. And in the next part, I'll be implementing all the functions. Like, let's say I'm using the convolutional function of the torch. I'm using pooling function of the torch. So I'll be implementing in the next video by my own. That will not be that much efficient, but by this process, you guys will get a lot like ideas how these are handled internally in PyTorch, and what you guys can do to like understand very much, oh, this like how this is how data is flowing, and this is where calculation is happening. So you have full idea, and you can integrate into your for the next project what you guys doing. You can have like some exciting breakthrough in between and like publish a paper. Yeah, so that's it. Like I'm going to share my screen, and let's have a quick chat there. Hi guys. So currently I'm on topic, and we will be like learning convolutional neural networks CNN, and like what CNN, what we CNN, how we reach to the CNN, and all this stuff we will be doing. Mostly the theoretical part, and I'll be also going with the code part to get you understand how we can use the pre-built function of the torch library to create a convolutional neural network and create more of these kind of stuff in a better manner. So yeah, like firstly, let us see like what we will be covering inside this thing. First, like history, how CNN like created from starting, and after that, like architectural overview, how these architecture are working or not. After that, like I'll be giving you one single slide of the mathematics, no more, no less. So you guys have a few formulas to get the size, dimension size for each operations, what is happening inside, so you have overall ideas. You can plan your next step or a step before what you wanted to attach. So yeah. And fourth, like I'll be going each layer in a like visualization step, like I'm showing you the matrix multiplication kind of stuff to get you more data inside that. And like after that, fully connected dense layer and softmax and training. Like this is very simple, so you guys can also understand very easily. I'll not be wasting so much time in the fifth layer. Yeah, so let's get started. Ah, okay. these this is the phase like how our CNN get evolved. Firstly, when like neocognitron come, this was the idea like, oh, what, like how these can be done, and this is like very fascinating. Like when neuroscientists in Japan, like Hubble and Russell, discover that like our brain is not like functioning like after seeing an image from our eyes. Our brain is not like working all at once. It's doing in layer by layer. So that's why like our brain work, and they thought like, okay, this is how all this stuff works. So why should not like we will be making something like that on the human perspective? Like let's say like our brain's first neuron and like few sets of neurons are like detecting the edge, few sets of neurons are detecting like shapes, and like that's why they called it like S cells and C cells. This is most of the biology part. And like after like taking the inspiration from biology, they like implemented a CNN network. Although like weights were handcrafted, like none of the weights were like already implemented and like come from back propagation or like any kind of ML training. These all were like just written by the hand, and like yeah. So next, let's move to the next neural network. This is the first time like when a person used like a computer to get the neural network done, and it was like very expensive on the computers to like learning a too long time for like training and getting these kind of impacts. So like this is the first architecture where like at AT&T Bell Live, like Jan has introduced LetNet 5. Like he used 5 layer we are ignoring pooling layer because like that's not any weighted layer. So two convolutional layer, three fully connected dense layer, and like approximately 60,000 parameters. And like it was trained on the MNIST datasets only. MNIST dataset is the handwritten datasets of image with like 32 by 32 or like 28 by 28 grayscale image you have like from 0 to 255. So this was the first like phase. Like this just proves that okay, we can come into this stage and we can have some of our ML model doing any kind of image classification and problem, and like our ML model can understand the image by anyhow using like convolutional neural network and the dense network. So this was like also a very great inspiration. After that, like AlexNet came. AlexNet was a winner of a like image recognition challenge, and in which like the ImageNet 2022 2012. So like it got a very good difference between the difference of the errors, like approximately 10% from the runner-up team, and it has like a very less error till then, like a 15.3% top five error only. So yeah, this were like very good thing to have, and this is the first time when any like a person has trained on GPUs. Like they have trained on the two GPUs, and like these were very revolutionary. They use dropout function. Like if you are training that much on the GPU, like you have started very few times on the CPU and directly you went to the GPU, then you guys don't have like you think like it will be overfitted. So they also thought, and like they used a dropout feature like that were not used by the most of the person at that time, because like they were not using GPUs, they were using CPUs, and they were not thinking about the overfitting kind of stuff. And like this is how they got a lot of stuff, and like they used ReLU activation function to like avoid lot of thing, and like it were very nicely, it were trained very fast, and they got the very good result. Like this is the first you can say the fully working and good accuracy CNN network. After that like two after that two like big network CNN architecture came at one in a single year only. One were like VGGNet, and other is like Google Net. GoogleNet and VGGNet. So in the there are the two different architecture of the both network. The first one, like VGGNet, is consist of like you are just layering multiple smaller convolutional network instead of having a big convolutional network scanning the image. So it also like saves your what we can say parameters, like it uses less parameters, and also giving you the more non-linearity to explore more inside your data, and you can get all the stuff done very quickly. Yeah, so like in VGGNet, the main point where like this architecture tells you, like if you just stack multiple instead of like making one big network, that will work more better. And this is the best point of the VGGNet. And the same year, like I told you, GoogleNet also came, and inside the GoogleNet, what they guys do, they guys like have a stack of like parallelly stack of in VGGNet we have like sequential stack of these all layers. And in GoogleNet, they got the parallel stack for 1 cross 1, 3 cross 3, 5 cross 5 cross 5, like convolutional, all type of convolutional network, neural network, and merge them all into a single like a layer, and then done this thing. And like it were only 5 million parameters, which is like approx 30x less than 28x less than the VGGNet. And the main like part how this got like very quickly is like instead of like a very big layer, 3 cross 3, 5 cross 5, like all, each layer will be this much only. They use like a smaller layer, like let's say 1 cross 1, 3 cross 3, so it gives them like less parameters also, and like very quickly also. And after that, like from Microsoft Research, coming like introduce ResNet. Like this is a very, you can say, at 2015 at Microsoft Research, Calming done a research paper where like it proposed the ResNet, and ResNet is a simple kind of a network where like instead of you are training f of x, you train for model your like f of x plus x. That means like you are training for f of x minus x, and your function, if you think of h of x equal to f of x minus x, so you are training for h of x, and you are getting all this data. And yeah, this was the first time like when you pass the initial data of the image into the back, like into the further part of my network. So let's say like if I'm going with a very big network, like let's say VGGNet and GoogleNet give you the opportunity to make a network your very big and dense, then like what will be your error will be like any back propagation will not be that much good. So you need something to like have your context and all this stuff going forward, and like making everything is done properly. So that's why like it introduced ResNet. So it's my cat. Yeah, so they introduced ResNet, and in the ResNet, they have done like passing all the like input, or like you can think of a access stage output back to like a very far away like network block. And by using this, they like have a very less error. Like they have done like top 5 error with 3.57%, and where like human is doing 5% accuracy. So it is like you considered as superhuman capability also. So this was like our first model which has more vision capability than human. And like these are few datas how you can arrange all this thing, like AliNet were 60K parameters, AlexNet were 60 million, VGGNet were like 138 million, and then sudden dropout. GoogleNet came with 5 million, ResNet came with 60 million, and the error is like also introduced here only. So now the part is like, what is CNN and what CNN does, how CNN does. So CNN is like, you have learned about the convolutional mathematical operation. This is a mathematical operation which you guys have done like multiple times in the like your childhood to multiply. Let's say you are multiplying 3,112 multiplied by 4,576. So you doing and like you're doing one by one to everyone and like summing this thing. This is called like convolutional. So using that convolutional, you are solving your like child grade mathematics multiplication problem. We will be using the same method to like get the information of a block. So what is like convolutional network? First, we can think of where this network works. So this networks work on a matrix, 2D matrix, 3D matrix, or any kind of like multidimensional matrix. It can. The main purpose of this, you can think of you have a camera and like you are scanning any kind of a matrix picture like one by one, sliding your camera and like taking full picture, full context of these all things. What this will do is like, let's say I have a matrix of 5 cross 5 and I have a 3 cross 3 uh, I have a 3 cross 3 my kernel or a filter. So I'll be firstly moving and like 3 cross 3, that means like nine. Nine input with the my image and my kernel multiplied to each other to give one single output. That means like we are combined the information of the uh, all nine indices of the matrices to one. So one has all the information of these, and using that only like we move forward and like go to the all direction and like do this stuff for all of our like points, and we can get the information about all these things. So yeah, this is like how you apply filter or kernel inside your metrics to get information. And the thing is like, firstly it like if you do this kind of filter and training on, you can say let's say image detection. So firstly in the first few layers, like you see it's detecting on the edge again shape, and then it goes to the object. And yeah, and like instead of giving all these, let's say like 28 cross 28 to directly fully connected, you have a like a bombarding of the like network, and like you will be your network will not be stable, and you have very big network for doing any kind of stuff. You can although optimize and any kind of things to that. And like this is a small architectural diagram what I can show you guys. But before that, let me check my recording where all working or not. Yeah, let me also plug my bad charger. Yeah. So let me go through the architectural of the CNN, how these all work. So let's say like you imagine you have an image. And firstly, we will go before the channel part. Like you guys have to know what is channel, and like you have a multiple metrics for a single thing. It's like you have multiple channels. You can think of like that. Let's say like I have image. What does image contain? You can think of like a big matrix, and each indices of the matrix contains like three different values. So instead of like storing them all in one single matrix, we will like create three different matrix for all like RGB. So there will be like three matrix you can think of. By the way, like there can be any arbitrary matrix for any arbitrary features you can also think of. Like it's although not depends upon only colors and these are kind of features. So that's is what like we are doing. Like firstly, we getting an input like from our diagram, we are getting a 28 cross 28 input. After that, like we are running a convolutional neural network into that. In which like 28 cross 28 cross 32. So like it's creating a 32. It's creating a 32 like layer for us, and like these all layers kernel will be learnable only. I think like I have to make sure my cat is not with me when like I'm recording. He's doing a lots of problem to me. Momo, Momo, oh, yeah, Yeah, so after that, like we let's say like we have a lots of very big metrics and we wanted to pool. Pool means like you are making sure to get you have a very big matrix, and from that matrix you wanted like selected data to be come to your new matrix. Let's say like out of five I only want, out of four you only wanted one, so you can like think of like I wanted the maximum, I wanted the minimum, and like I wanted which satisfy this equation, or like which has the closest value to zero to this equation. You can have any logic to pull here, and this will also be a very nice part if you like find some very good algorithm to like pull, and like it will be much more stable after that. So we are like just making sure like if I have a 5 cross 5 matrix, how I can convert into 3 cross 3 matrix using the pooling. Or like here we are like dividing by two, like 20 from 28 cross 28 cross 32 to I we made 14 cross 14 cross 32. Like pooling does not change any number of channels. And after that, same like we will apply again convolutional neural network and again like pooling. After that, like we have a like set 64 layer of like matrix, 64 matrices, and we wanted like to make sure all metrics become one flat list. One flat list. We are making one flat list of the all these like matrices, so that's known as flattening. And after that, we will be doing like passing these all to our fully connected layer, that may be one, two, three, four, depending upon their. And like yeah, let's come to the mathematical part. In this mathematical part, like you can think of like uh, in this mathematical part, like I'm going to you very simple kind of thing, so you have know like how the shape, what will be the shape and like dimension of the stuff what you guys are doing. So the shape and dimension will be like very simple. Like for any convolutional network, like you have a simple formula, like your output size will be W minus K plus 2P upon S plus 1. So S, this is not S plus 1 in the like denominator. Denominator is only S, and like after that this is plus 1. So I wrote it very badly. And yeah, so W is like your input size, your matrix. What is your matrix size? And K is your kernel size. Like what is your kernel or filter size, which you are applying. Let's say I told you now I'll be applying a camera, and like so how much camera can capture at once. This is what. And like P is padding, like if you wanted to add some more extra layer in the boundaries of your input, so you can have the P. And S is right, like how much my uh, filter are moving at once. So let's say like I wanted to move one by one, or if I move two, like it will be moving two step one and like two step in every direction. And after that, like you can get the formula for like is if you wanted your convolutional neural network to get the data of like let's say multiple into one, but you also don't want your like size or dimension of your matrix to be decreased. So like you can get the padding from here, like how much padding you will get to like get the same dimension. So this is a simple formula. Like you can calculate the padding equal to kernel minus one upon two, the get the size of your output as input. And yeah, this is like if you wanted to know the number of parameters, you can go with like multiplying your kernel square with the input channel plus one multiplied by the output channel. And yeah, you can think of like this is my grayscale image. Grayscale image I'm saying because like from 0 to 255, this is the only input, like any value can lie inside this thing. 0 to 255. 0 means like it's fully black, and 255 means it's fully bright. So you can like think of anything between that is a grayish thing, or like little bit toward white grays, like and toward gray, black grays kind of things. I'm not like that much color person, but you can understand like how these are identified as another thing. So let's example this as our input size, and like MNIST has the data sets of 28 cross 28, and like I'm just showing an example of 5 cross 5. and with one channel only, like if you use any image for that, real image for that, they may have three channels. Like if they are colored image, for grayscale image they have one like channel, or like some image also has four channels, like some are called alpha channel. Yeah, so after that, like we know how to calculate the convolutional. So you can think of like the box we are made on the input is the same box size of the kernel. You can see kernel is like 1 0 1 0 1 0 101. So these are the X-shaped kernel of mine, and I think of like this kernel values comes from the training of somewhere. This may not be only 0 and 1. This can be any arbitrary number. Okay, so you like taking this kernel and placing at each input one by one, and like multiplying each what is going behind, and adding and like add to the your feature map, which is called output. Like output is your called feature map here, and you do for all the stuff, and like after that you move it one step right and complete your right thing, and then you come to one step down and do the same thing. And one step, I told you, like one step can be also variable. It's called stride. Like if you had a stride equal to 1, then you only move one step, and if you have stride equal to 2, then you have to move 2 steps. We will be like looking into more detail of these things in next like slides, in next few slides. So think of like I'm calculating this, see how these are calculated to get the more ideas. So see now my convolutional neural network completed, and like we got a feature map from the kernel, and this is our input. So using this input we can get the feature map, and like this five can contain the information about the all first like top corner nine element. After that one is like getting the is um, from one index to like nine element of the both. So you can think of these as this reduce the size, but like this has the more data, more relative data. You can think of like their data can relate from each other. And now, like I told you about the stride. Stride is nothing but like how much you wanted your uh, kernel to move at once. Like let's say like if you have a stride equal to 1, so it will be move one step, one step, one step. Let's say like you are at I equal to 1, and your end is like I2 equal to 3. So if you wanted try equal to 1, which is default. So if you, sorry, I equal to 0 and I equal to, I2 equal to 3. And if you wanted stride to be 1, so you increase 1 in the both. Like in the I, you increase 0 to 1, and in the like I2, you increase from 2 to 3 to 4. So you will be skipping one thing, and like same you have to do in the while layer also, one by one, one by one, one by one. Firstly, like you complete single axis, then just drop one your layer and do the same thing. Or like you can drop two layers if you are adding two stride equal to two. Stride equal to two means like your x will be plus by two, and x2 will be also plus by two, and same for y and y2. So this is how you move into your like metrics to get all the stuff done. You can have any strive, like any arbitrary number, which is not like greater than your input size. And the formula, like what will be the tape, is same. Like if you're not applying any padding, w minus k upon s plus 1. And padding is like very simple also, and like you, let's say you have in a box, you want it like let's go with first thing. Like let's say you have this 3 cross 3 matrix, and you take 2 cross 2 matrix. You go with the first stuff, and then come to the second, then come below and come. How many times do you think like the corner 4 will get involved? They will be get only one involved. So like only one other thing has their information into that. So you wanted to expand and make your knowledge more little bit global, so you can understand all these things easily. You can share your information with more, so you have more relative information, which will be helpful in future predictions. So we can add like extra. If you say like padding equal to 1, we will add one layer into the both all side, and like It's not layer. You can think of one. We will be increase one dimension from all sides, so it will be although increased by two dimensions. Uh, and basic fill will be like zero. You can fill zero with all these things, so you can have on your original data, or some does like filling the last, repeating the last layer in all these things. So that's also a good thing. And next thing what we can do is like we can also use padding to like give the value to our edges of the image. Let's say something important is in the edges of our image and we wanted to tackle that, so we will be not able to sharing information without padding. So that's why we add padding there, and like we use edge sharing and like giving a little bit more value to the edge to do all this stuff. However, this is very simple, like activation function ReLU. This activation function does like this will output you 0 to x max. Like what will be the maximum of your input between 0 and x. This will give you. So if any positive value you give, it will return you same, and for any negative or zero value, it will return you zero. And you can see the example below, like -2 pump up to zero, and like 3 remains same, and all this stuff. Yeah, so I told you about pooling, making so like making your input bigger, making your input smaller from bigger matrix. So let's say like we have a lot kind of a pooling, and you can also have your any kind of algorithm for pooling. Okay. And here, what we are doing, like we are making sure for each four values, we are getting one values. So we can have average pooling. Let's say we wanted to average all, then make it to one, or we can select the maximum one. We can select the lower one. We can have a equation who is like more closer to satisfy this equation. I wanted to select that one. So this kind of stuff you can do, and you can pull. So you can think of like here I'm like doing max pooling. So I wanted to maximum value of each to store there. And I'm also using like a stride equal to two. So see, this is moving two step at once. And yeah, I can again show you one thing. Like you can think of uh, this how these all are done. Like you think of like 6, 8, 3, 9, and the maximum is 9. Again, like you took 2, 4, 1, 5, maximum is 5, and same for the like 7, 2, 4, 8, maximum is 9. Why we not do 3, 9, 7, 2? Because like we have set the stride equal to 2. So that's why we are skipping one step here. And yeah, so what you will be expecting your like if you are stacking multiple layers of convolutional neural network and like pulling layer together with that, what you will expect your layer to behave and do the stuff. So you can think of like your lower level, like which will be like a starting layer 1 to 2. If I'm having very small network, so you can think of 1 to 2 will be able to get the edges, corners, and gradients and textures, how these are behaving. Secondly, you can in the mid level you can started getting the shapes. Let's say like you get the face shape, you get the eye shape, you can detect the eyes, you can detect mouth, you can detect fingers, and like you can do some kind of stuff. And like in the layer more than like a higher level higher level layer, you can get the full information about these all things. Let's say I'm having a human, my photo, and like it knows I have 5 fingers, I have wearing a t-shirt, I have my face, I have my hair in the next layer. So yeah, you can think of like if you go deeper in the layer, you have more information about the input. And yes, flattening is very simple. You mix the 2D array to 1D array. So just by arranging like 9, 8, 2, 7, 5, 3, 4, 1, 6. So you just arrange all these together to make it 1D. Nothing fancy, nothing. After that, you can think of like a simple, fully connected dense layer. This is normal neural network, like you can think of, you just created by the neural network, and you linear neural network. One is connected to everyone, and this is giving you the class as the output. And in the output, like this give you the uh, this gives you like how any number, random number to all of your output. So you wanted to like make sure everything to a probability distribution. So you come to Softmax to create these things. After that, like let's go for the coding path. Okay, remove this thing. I've removed like these all are the outputs of the previous run I tested. And let me check my recording is working. Okay. Okay. So firstly, like I'll give you introduction of all these like files and also showing you the demo. So first you can think of like we will be showing you mostly of the MNIST data. So how the MNIST data look like MNIST data. Okay. We are downloading in .data folder and like just showing you few details like in the plot how this will look like, also logging you the shape of the image, what is the shape and like what is the label of the random what we took. And yeah, so let's get show you. So this is the first input of my MNIST data set. This says this is 5 and like this also look like 5. And you can think of like heat maps display it a little bit better, so that's why I added heat map here to display. This is the normal representation of like you can think this is the black and this is white. This is perfectly zero and this is like one. And second, you can think of like convolutional, like you know the convolutional operation. So I'll be showing you how convolutional operations work. So you can just think of like I'm creating a kernel by manual my hand. I'm not training it. So you can think of this as edge detector kernel. How edge detector kernel you can think of like let's say I'm adding all borders as a -1 or like very lower number and center as a 8. So what this will does like if I'm like at any kind of place, if I will be placing my main element at the -1 position only. So what my main part will be shrinked and my neighbor part will have like more information. My neighbor part will be more aggressive on me. So that's why like I can get the more values from my neighbor, and then I can think of like I can have my edge here. You can like have any kind of a kernel, like some kind of a conventional kernel to make you blur, like Gaussian blur in your phones, and systems are working using same convolutional patching applying. There's like a lot of any kind of numbers you can pass and like you can blur your image. And yeah, this is like it. I'm just giving you a tensor and like I'm just changing after creating like NN dot convolutional 2D, this create your convolutional neural network. I can just tell you about the input, like it says input channel, how much channel you will be passing to it. I'll be passing one channel. How much output channel, what you are expecting. I'm expecting one output channel for this thing. Like I just wanted to take the edge. Uh, what is your like kernel size? I have kernel size of 3 cross 3. What is the stride? Like will go stride equal to 1 default moving. What is the padding? Padding like how much we wanted to add extra to our border. So I added 1. Like these are all the stuff that you can go with. And like by initializing it, like it's although initialized with your random weight. So we like added our own kernel here. So it has all the stuff. After that, like we test it out and pass our image into the our network, like conventional layer, and check what's the output. And like I have printed here. After that, like I also created a one real conventional network, like where I'll be not having anything, and I want like one input and 32 channel output, kernel size of 3 and padding equal to 1 same. So this will give you 32 output, 32 different outputs you can think of, and each will be like 28 cross 28. 32 feature map for 28 cross 28, and you can see from like output also, and I'll also giving you the number of parameters what this use, and like I'm printing eight any like feature map. Also let you show you. Yeah, so you can think of this is the original one, and this is our like edge what we have done. You can think how much value we are giving to the edge. This is what we have done, and these are all the filters like applied by the convolutional. You can think like how random these are doing, making blur and all this stuff. Some are focusing here, and this will be learned. Like this is not that directly random stuff. This will be learned by your model when you are training anything. But there is also few known. So this is what like edge what I showed you, and let's look into the output. So yeah, I printed my input size. What I told you, like this is one batch, one like channel, and 28 cross 28 image. This were like our one image. Output is like also one cross 28 28. For the first like custom tensor that we have defined here, this one. And for the real convolutional network, which like has weights created by its own, for that like you can think of we are passing one batch, one channel 28 cross 28, and output we are getting one batch 32 channel 28 cross 28. Parameters are like 320. Next is ReLU. Like ReLU is very simple. This will just tell you how your activation is working. I have a graph. You can understand from graph anything before zero will be remain same, and anything below zero like will be same. Like one thing of two is converted to zero, and three is stay three. Five stay five minus four converted to zero, and all this stuff. And this is what like I'm also logging also. Like this where your matrix before ReLU and this after ReLU. Yeah, so now is little bit more uh, good aggressive part, like where we will be doing about the pooling. So we have two poolings, like I'm doing your max pooling and average pooling. I told you you can have any number of and any kind of a pooling to do. So firstly think of like max pooling. What we are doing max pooling, we are placing our stride here. And like think of like I'm adding my stride equal to 2. So I will push my kernel here and 6839, which is the greater 9 I put here, and I moved by 2. Like I have to move here if I had stride equal to 1, but I had stride equal to 2, so I'll be moving here. I move here, and in that I choose 5. Same like here I choose 8. If like I had stride 1, I have to move here, but like I had stride 2, so I'll be moving directly here, and after that also directly here. Same for the average, like same for group will have the average, and he'll storing it here. That's all like max pooling and average pooling. So let me show you first code, and then we will go to the output. We are using the like a neuron max pool 2D, and this takes the same most things kernel size, stride, what stride you wanted, what padding you wanted to your like image and to matrix, and like it will give you the all stuff. This is random, like I created 4 cross 4 example in which like I'm applying max 2D pool that I told you maximum, and this is like a map of which feature map we are pulling. Think of like we just pull, we created these things and we pass our feature map. I created a random and like passed here to get to the examples how this work, and like for the average also we pass our input into this thing and get the output is here, and we like printed it here, and after that like I'll visual I plotted few chart to you guys to show there, and this is what it look like here in the input. This matrix I'll applied output we use like after this max 2D pool. This is our like output to cross true, and yeah, this is like all the steps how this will work, and this is the how it will work in the real scenarios if you use this kind of a pooling. Now come to the main CNN part. It is like the main core part you can think of. I made my full network. So think of like I use convolutional 2D to create my convolutional lead layer from like I'm giving one input wanted 32 output, and kernel size I give 3, and padding I wanted to add one layer of padding. I also created second convolutional layer where like I giving input 32 layer, I wanted 64 layer output, and 3 layer of kernel size, one layer of padding. And like pooling is like we wanted pooling of the kernel size 2 and stride 2, like that what we are showing you. And one like activation function ReLU, and two dynamically like a dense layer neural network. So here what you can do is you can get these how these data came and what is the size and all this stuff of this. So firstly, let me run this file. This will not give you any uh, graphics, I can say. This will not give you any graphics. This will be mostly local only. So I'll be going to the forward path here, but first let me go with your how these sides are made, so you have a clear assumption of all this stuff. Yeah. So think of like firstly we have the conversion here one, which has like 32 layer output and one layer input and three layer 3 cross 3 kernel. So you can calculate very quickly, like you wanted 32 cross 1, 32 from 1 with 3 cross 3, and you got like 288, which is here. And bias are same, like but this for 32 layer, it has 32 different biases. For the second, like you can think, I wanted 64 from 32 and 3 cross 3. So 64 from 32, you got this number, and like this is 8. And these are like normal layers, so you know how these are calculated. And now come to the like part how we are doing our things. Like we are getting the size 1 cross 1, like for one batch of one channel 28 cross 28 of the first print, and after that we are sending it to the first convolutional neural network. This is my first convolutional neural network where I send my data, and this printed. After that, I'll also pool it, and before pooling, I'll have applied ReLU. So this is the data after pooling. So you see, after convolutional, it becomes like nothing. Like it just changes its layer from 1 to 32. Uh, and after pooling, like these like channels are remaining same, just like it half the size. And again, we pass to the like a convolutional neural network. It's double the 64 the size, and like this won't be change any convolutional. And we do the pooling after that. After that, like we flatted our this into one single list, and we applied the connection. So same thing here. You see, first I applied convolutional one, ReLU and pool, convolutional two, ReLU and pool, and flatten, then like ReLU and our network. And now let me show you by training a small like 5 epoch example. So while it's training, I'm also showing you the code. It will like not take more than a minute. So like this is simple, the same like CNN what I told you there. This is the same thing, just it does not have any comments. I create a transform like which I will be getting data from the MNIST. So this will be a list. So I wanted to convert to tensor, and I also wanted to normalize like by the mean and standard deviation. I set the mean to like 0.5 and standard deviation for the standard 0.5 for my data. And after that, you can think of like I break the train set and test set, and like I created a model here, create a Cartesian here. Like this is how it will like it can like you can think of create a loss, and this is optimizer. This will blame each weights you because of you. Like I got this much bad, and it will also apply like you need to uh like fix it by beating. Like let's say you can hit you clap 3 times. You say go back 3 steps, and I'm doing 5 reports. I just running the model, and like after that taking from data sets, passing to models, like passing to the model and like calculating the loss, checking blaming the like weights and up like setting the weights to proper, and this is for like any other calculation. And after that for the evaluation I took the rest images and try and tested what is the actual accuracy. So you can think of like for first report it gives you 95%, second 98%, third 99%, fourth 93%, fifth 94%. And for evaluation, like this is the 99.03%, like nine all 99,000 9,903 out of 10,000 were like current. So now let's like using the same model that we go through, predict one, like predict random 10 images. I'll running it multiple time to give you like random. So this is five, like I even can't recognize this thing. Five, this is one, four, and this is the status like confidence what my model like predicted. So you can think of like this learned very fast. This is overfitting, I know, but like you can think of this is working fine, and the same you just need to add to dropout and like add more layers to make sure all these things work. This has like 99% only for the seven, and this is two. Oh my god, this is two. How this is looking to two? These are the confidence like by my model. Okay, true is also two only in the dataset. So yeah, it's learned from here only. Ah, okay. Now we have very few slides left, and like let's go to the slides and see what we have learned. I've spoken too much. Like I've recorded this video twice. Once like the first were like very smooth and very like I was impressed by my uh quality of the video. But like I know in the second recording I won't able to get that much quality recording. And in the first video also like in the first video, I'll like when started recording, I'll recording my different desktop. And there's a glitch of the OBS which were not like after changing desktop, it's not recording that. So I think that will be fixed here. And this is the like forward pass with pass. You pass the, your image to the model. You want the prediction. After that, you say what is the loss, like actual loss. Calculate the loss, and after that, like you blame game. Like you go to the back and each layer you say you are the bad for because of you. I am like here and blame each other. And after that, coming to the and there will be one teacher going like which update the bed. Like each weeks, you need to change this much to make good, and these all run in the loop. And you see, this is the network type, like you just see in the code. First, I took the input, I then convolutional one, passed it to the pooling, and then again I applied convolutional neural network, then again I pull it, then flatten it, then like pass to the dense layer and move forward. And you can think of like where these CNNs are used. So you can think of like CNN are used on like image classification, let's say like dog versus cat, like YOLO, Zolo. You have think of lots of models if you know. These are famous things. And object detection is also like the same. And you have let's say like I'm at airports, I'm lying this detect it's as a airports and your camera is detecting it and like my face and highlighting it like as a box. So this is also of the detection and face recognition. If you wanted to unlock your phone, like you if you have iPhone, you just unlock and like you see, oh, this is going very well. Although iPhone use like not image, it's use different sensor but use the same CNN to predict your face. And next is like image, medical imaging like MRIs and CT scans, like where doctors get suggestion from the ML model only, like you may look into this part look weird, and also for the video analysis and NLP and audio task. These all are like you can think of any metrics uh, you can feed into it. This will work very fine. And yeah, these are like all the things what you can think of the CNN from the thing. Thank you for watching, guys. Like, have a like, subscribe, share, and like, first you, if you don't like, don't subscribe. I don't will like matter anything, but please give me a suggestion for my video recording style and like for my speech. Like, I don't have very good communication skills. Also, my English is a little bit weak. Like, I have spoken broken English in this video a lot, and all these things together with the main point will be like, you guys please let me know where I have done the mistake in recording the video in the technical part, or like what I need to learn more in the technical terms, so like I can explore more on my side also, and help you guys also to like give you the research in very short time. And yeah, this is it, like what I wanted to say. I started my this channel. I started my this channel. I started my this channel to share the knowledge is what I have, and like I also make sure I'm getting like more knowledge, and I'm getting a little bit more experience and hands-on on all this stuff. So like if I will be creating videos, I'll, because of that, I'll also like implementing each papers what I get newly, not only like leaving by reading. So it will also help me, also help you guys. I'll also learn along with you. So yeah, please like give me any comments what you guys think about improving of me, and me as a personal, as like technical, and as a communication skill. All, please, thank you. Have a good day.